All right, Kevin, over to you. Oh, one more thing. I'm sorry, I forgot to mention. We do have some concerns about bandwidth. So if you're not speaking, we ask that you keep your camera off and of course, keep yourself muted. But when you do have a question, feel free to pop that camera up so that we can see you and know who we're talking to. And now I'll turn it over to you, Kevin.
All right. Thank you, Christine, and thanks everybody for being here and the opportunity to speak again to my favorite people in Region 10. So I looked at my last presentation I gave in Region 10. It was only 9 years ago. So I think that you guys probably are ready to hear me again. And it's going to be a great training session, I hope. You know, again, I missed that feedback from the audience, so you guys are going to have to help me. I don't say what you want me to hear about something. Let's somehow or another communicate that to Christina. She'll bring it to my attention and we'll talk about it. I'm going to talk about anything you guys want to talk about, of course, and give you my Mississippi perspective and try to tie in some EPA stuff and think about how you guys might want to interpret some of this stuff. So that's what we're going to do today. We'll kill my camera and save some bandwidth. And we're going to talk a little bit today for just a few minutes about spill bucket and containment sump testing. And for some reason, this has caused a lot of confusion for people and don't really know why. It should be pretty simple and straightforward with spill buckets, and it really is. So I'm not going to spend a lot of time talking about spill buckets. There's not a lot of exciting issues to talk about, but we're going to run through the basic procedure and just bring up a couple of things to think about. If spill bucking is new to you, then I don't know, maybe this should be talked about more, but we have been doing this in Mississippi since 2008. So been a long time. I think it's an annual test in Mississippi, although it's a 3-year test in the federal world. But when we look at this, and we're going to talk mostly about RP 1200, PEI RP 1200, as we all know, is the test document, or the document that PEI produced a few years back to describe how to do all this testing. So it was a very timely document. I was on that committee, a lot of discussions about how to do things next. So I'll throw in a little bit of the committee talk and meetings that we had about RP 1200 and continue to have about this testing stuff. So spill buckets are not something that are complicated. We all know they're really just a 5-gallon bucket or less that just sits on top of the fill port. So RP 1200 has both a single-walled and double-walled test procedures. For a single-walled spill bucket, the vast majority of people are going to do what we call hydrostatic testing. Although it is possible to do vacuum testing, we have found that to be pretty difficult and not practical. With double-walled spill buckets, it's very easy to do vacuum testing typically. So both are described in RP 1200, and I don't know why, but I'm having trouble controlling this, Christina, but we'll get through it. Here we go. So the first thing you do with RP 1200, of course, is clean the bucket and visually inspect it. Because obviously, there are a lot of times you can look at a spill bucket and tell there's no reason for me to try to test this. Sometimes it's really, really apparent that it's not going to pass the test. So that really is the end of the test. When you look at a bucket and you see something like this, that's it. You just write fail on the test and it's a visual fail. Spill bucket testing, again, is usually done with just what we call a hydrostatic test. You fill it up full of water. So clean the bucket out. If it looks okay, then you fill it with water to within 1 to 1.5 inch of the top of the bucket. And that top means the plow ring. So you have to be within 1 to 1.5 inch of the plow ring with the depth of the water. You can't just put 2 inches in the bottom and call that a test. It has to be filled completely full of water. And it's really nothing more than measuring the depth of that water to the nearest 1/16 of an inch and monitoring that for 1 hour. So a lot of discussion in RP 1200 committee meetings about how to define this. So really, we just settled on this so-called qualitative test. It's not a leak rate test, really. It's just a pass or fail, straight pass or fail. If you lose any water, basically, it's a fail. And you pass if you do not lose any water. So that's why we have that 1/16 inch thing in there, because the 1/16 of an inch is very commonly what we see on rulers that people use to measure water with or measure the depth of the water with. So we decided on that 1/16 inch criteria. So basically what that means is you can lose 1/16 of an inch over an hour and still pass the test. Okay, so 1/16 of an inch is very difficult to see on a ruler when you're trying to measure water. And one of the real tricks to it is having that ruler in exactly the same place at the beginning and end of the test. Because it's very easy to move the ruler slightly and get a different 1/16 of an inch reading. So spill bucket testing, the hydrostatic test, again, just a gross pass or fail. There is a way to do vacuum testing on single walled spill buckets also. These systems have been around for a long time, although there are very few on the market now. They're almost impossible to find. And so for that reason, you just don't see hardly anybody trying to do vacuum testing on single walled buckets, or very few actually. And part of the problem with this test method is, of course, you have to be able to get a lid to seal on top of the spill bucket. So getting that lid, this temporary lid to seal so that you can pull a vacuum on the single wall bucket is, of course, the big problem and the issue with this test. And if you get a fail, then the question is, okay, is it the lid that caused the test to fail? Or is there something wrong with the bucket? So what you typically wind up doing is in a fail is you take the vacuum test off of it and you do a hydrostatic test anyway. So I just don't see a lot of people doing vacuum testing on single wall buckets, although the method is described in RP 1200, and yes, it is possible to do that. All it really is pulling 30 inches of water column vacuum. That's a very small vacuum. 30 inches of water column is about 1 PSI. So it's really, really small vacuum that you pull. And again, it's just a 1 minute test. If you can hold 30 inches water for 1 minute, then you pass. So if people look at that 1 minute thing and go, hey man, this is really quick and clean, there's no water to worry about. So they want to try to do this, but it's just not very practical given the technology that we have today in our experience. Double walled buckets, you typically will see them being tested with a vacuum. So here, most double walled buckets will have like a Schrader valve built into the interstitial port. So all you really have to do is connect your vacuum hose to the Schrader valve, and you pull a very small vacuum on the interstitial of the double walled bucket. It's just 15 inches water column, which is about a 1/2 PSI. And you monitor that vacuum for 1 minute. So again, this is a really quick, easy way to do a double walled vacuum bucket test with just vacuum. And when you test the interstice of a double walled bucket like this, you are testing the integrity of the secondary bucket and the primary bucket simultaneously. So you'll typically see this done, a lot on double walled buckets. So there is the EPA has an exemption to the requirement to have to test a double walled bucket, right? And everybody knows that if you have a double walled spill bucket and you do the monitoring of the interstice of that double walled bucket, you do not have to do the integrity test. So the question becomes, what is the monitoring that is required on a double walled bucket to get you out of having to do the integrity test on the bucket? So just a couple of pictures here. The one on the left is one of the early styles, and they're still around. But the interstitial port is monitored with basically what amounts to a dipstick. It's just a little, like an oil dipstick on your engine. You just unscrew the little dipstick, pull it up and look at it, and if it's dry, everybody's happy. If it shows any kind of liquid, then we have to do some other testing. The picture in the middle is one of the earlier styles of the so-called, I call it like a fuel tank on a tractor gauge, because really all it is a little float mounted on a little corkscrew shaft. And this float moves up and down based on whether or not there's any fluid in the interstitial. And so you see kind of hard to see in the picture, but it has just a little red arrow that points to a quarter, a half, 3/4, and then full. So it just shows you the water level in the interstice. And of course, you want it to be showing empty all the time, right? And then the bucket on the right, the far right, that's a style of interstitial monitor where really it's just a green is go, is good, and red is no go. So you see green, that means there's no fluid in the interstitial. You see red, that means something has tripped a little float switch. And again, these things have been quite problematic in our experience, the little sight gauges, whether it's the arrow one or the green red one, they are very, very touchy. Once someone fools with one, once you pull it out of the bucket to try to see what's going on, getting it back in the bucket and getting it to behave right can be very tricky. So I personally just don't have a lot of faith in just looking at these little sight gauges and being able to tell whether there's anything in the interstice of a bucket or not. So we pretty much don't care about it. We don't have a double walled bucket requirement in Mississippi anyway. So if you want to have that here, that's fine, but that's not going to get you by having to do the test or not. And so another reason for that is, of course, when you talk about monitoring the interstice of the double walled bucket with these little sight gauges, the idea is you could literally just go out once a month during your normal walkthrough inspection routine and note the condition of that sight gauge and keep a written record of that. And that would suffice to show that you are monitoring the interstice of that double wall bucket. I really don't agree with that. It's like the old double walled tank issue with an atmospheric interstice. Just because you have a sensor in the interstice of the double walled tank or spill bucket does not mean that the secondary of that spill bucket or tank is tight. The bottom could be completely blown out of the bucket or the secondary of the bucket, and your sight gauge would appear normal. So it does nothing really to tell you about the integrity of the secondary of the bucket. So if you do have a spill bucket that fails, then you got to ask yourself what next. Well, obviously you can install it, tear out the old one, install a new bucket. That's fairly obvious. And there are these kits that are available on the market today to retrofit existing buckets. There's several of them out there. The bottom right picture is a stainless steel so-called kit that's being retrofitted on an old bucket. And they actually do work pretty well in our experience. They're kind of difficult to get in, and the riser pipe has to be absolutely perfectly clean for you to be able to get these kits to seal properly. But if you get them in, get them sealed up, they seem to be very good and very durable. So I don't really have a problem with people doing the kit. And these days, just like everything else, there are supply issues, supply chain issues, manufacturing issues, all kinds of these issues that you really cannot get your hands on some of this stuff in a timely manner. So if you have a failed spill bucket, most people will say, well, you got 30 days to replace that bucket or fix it. Getting the spill bucket in within 30 days is a trick in a lot of cases. So sometimes it may take 2 or 3 months to even get the bucket or the kit that you need to do the work. And so time frames on repairs have become a real issue and a problem, which we sort of have just had to look the other way, quite honestly, relative to a lot of this repair work going on, because there's nothing that can be done about it. It's a supply issue. And there are some people who have tried to do repairs on their buckets. And some of it's pretty comical, pretty funny what people will try to do. And I don't blame them for trying, I guess. But that bucket on the top left, that's the old Bostic 1100 caulking material that's been around forever that we use to try to help seal penetration fittings, is what it was used for. They've tried to fix some cracks and holes in their bucket with that. The top right picture actually is Bondo. That's what you would put on a car to fix a dent. That's Bondo is what that is. And so the people have done a lot of crazy stuff. And so the question always becomes, well, if you're going to do a repair, does it comply with the manufacturer's requirements? And obviously, if you look at what the manufacturers have or do not have relative to being able to repair a spill bucket, you're not going to find a lot out there. There is not much guidance out there anywhere from any manufacturer about how you can repair one of their buckets. So essentially what you're looking at is if the regulator will allow you, you put one of the kits in, or you have to tear it out and replace the whole bucket as an assembly. So it's just one of those things we have to deal with. And so spill buckets, again, a lot of spill buckets fail. The spill bucket kit is a single walled kit. They do work pretty well, like I said. And so the question has become again, like, if you're going to do this kit, is it a new bucket or is that a repair? And so if we go back to that picture again, the bottom right picture, if you look at that, and you'll see that stainless, it's basically a stainless steel insert that has a seal, a compression seal around the 4-inch riser pipe. And so when you have that kind of scenario, let's just say it was an OPW spill bucket originally, and you're going to buy this kit from, just say, Imco Wheaton. So you want to put this Imco Wheaton kit in this OPW spill bucket. And so does the regulator consider that to be a repair, or is putting the kit in a new bucket? And so if it's considered to be a repair, then you actually cannot do that, because OPW is not going to recognize that Imco Wheaton kit as being an acceptable repair for their spill bucket. So, I mean, that's just the way it is. That's the kind of crazy stuff that happens. And so most people have said, well, if you put the kit in, that's a new bucket to get around that. So it's not considered to be a repair. It's a new bucket. And so that's the way a lot of people look at it. And I don't have a problem with that. You just need to be aware that that issue is out there and has been for quite some time. So wouldn't it need corrosion protection? This is a stainless steel bucket, and it's no different than any other bucket. No bucket is required to have corrosion protection. That's one of the things that, you know, I'm a CP guy. That's what I do, is cathodic protection. We have all these steel, carbon steel, stainless steel, cast iron bases on these spill buckets. None of that has any kind of corrosion protection on it. So it's just, it doesn't routinely contain product, right? So it doesn't have to have corrosion protection. At least it's not supposed to routinely contain product. We'll say that.
Kevin, we just had another question pop up in the chat that says, what testing is required for a manufacturer to state the material is okay for a repair? In other words, if people are using tank lining epoxy for a spill bucket repair rated to be in direct contact with fuel, why is this not an appropriate repair?
Well, the short answer is you would have to get the manufacturer of the spill bucket to say that that's okay, right? That's when people read the rule, and when they read 40 CFR 280, it talks a lot about in accordance with the National Code of Practice and the manufacturer's requirements. You know, that's what repairs have to do, installs have to do. So you have to do both. And so actually, you know, there is finally a repair code of practice out there. It just came out a couple of years ago. And so you could meet that, but getting a manufacturer to say that that third party epoxy or whatever it is an acceptable repair to their bucket is probably not going to happen. Yeah, that's a good point, Dylan. You know, when we talk about containment sumps and repairs on containment sumps, everybody just looks the other way, don't they? And so that's what I actually was saying is, on spill buckets, if you wanted to accept that, you just look the other way. That's what we have done here in a lot of different cases, just like, you know, trying to fix all these old containment sumps with PCI or Bravo or whoever it is, Daco. They all have their own products to fix these sumps in kind. And none of them would be recognized by the sump manufacturer, but everybody does it. So it just kind of becomes one of those things that we just don't pay much attention to, quite honestly. And so that's spill buckets. All these same issues apply to containment sumps, which we're going to talk about now. And so a little bit more issue to deal with here on containment sumps. So when we started looking at this again, and in Mississippi, we've been doing containment sump inspections since 2008. That's been a requirement here. And so when the federal EPA came out and published their guidance on this and the rule, it was kind of puzzling to us. But when you read the EPA guidance, this is the way they define these manholes and sumps. So the picture on the left, I'm sorry, I'm having trouble navigating here, Christina. So I don't know why it's giving me so much trouble, but
I'm not sure. Kevin, do you want me to just do it and you tell me when to advance?
maybe so. I don't know why
Okay.
I cannot seem to control it.
Okay, is this the right screen?
Back up one slide. Yeah.
Hold on, I got to turn off your remote control. There we go. Is this the right one?
Yes.
Okay.
So now we're on containment sumps. And this is the first slide for containment sumps. And so the way EPA defined this was contained sump versus uncontained sump, which is just kind of weird to us. And there's not too many people I know who talk like this. The bottom left-hand corner picture, that is a containment sump. And so in EPA's definition, I'm sorry, that is a contained sump in their definition. The next picture to the right is also a contained sump by EPA's definition. The picture in the middle, the third picture, that is just a uncontained sump by EPA's definition. And yes, they do call that a sump, even though it's not any real structure there. And then, of course, the spill bucket is also considered to be a sump by EPA definition. So next slide. This is the way that we look at it, and I think everybody else does in practical terms. What EPA is calling an uncontained sump is just a manhole. There's no bottom to this thing. It's just a skirt, manhole and a skirt. There's just sand in the bottom of it. Yes, there's still plenty of them around in these old single-walled systems. So that's just a manhole. That is not a sump to me. The picture in the middle, we'll call that a sump because it does have a structure to it, even though it obviously is not liquid tight. So because it doesn't have to be liquid tight in our regulatory world, because it was put in before the secondary containment requirement went into effect. So that sump doesn't even have to be there. There is no double wall requirement. So just because it's full of water, we don't care. It doesn't matter. That is still a sump, but it's not a contained sump like the picture on the right. The picture on the right is a contained sump, and that sump has to be liquid tight. Therefore, it has to remain dry because that system on the right is subject to the double wall requirement. So I think you'll hear me talk about sumps a lot. And when I say sump, what I mean is that picture in the middle. If I specifically say containment sump, then that is a sump that is supposed to be liquid tight and dry, and everything else is just a manhole. Okay, next slide. So then there's a question about whether it's a quote new versus quote old sump. And this is pretty straightforward for us again. And every state, when they implemented the 2015 Energy Act requirements, 2005 Energy Act requirements that required secondary containment, everybody has a different date that their state rule changed. In Mississippi, it's October of 2008. That's when the Energy Act rule was implemented in Mississippi that required everything to be double walled. So a new sump is, of course, any sump put in on or after that October date in 2008. And An old sump, obviously, is a sump that was put in before the secondary containment rule went into effect. So the bottom right picture is the way most of those look these days. They've long ago been abandoned as any kind of, quote, contained sump. They're just a structure that we call a sump. It's full of water, and that's all it is. They do not have to meet the secondary containment rule. So when I say new versus old, that's what I mean by that. Next slide. So when is testing required? All right, so for a new sump, and again, we know what new means now, you are required to do interstitial monitoring, of course, and so that sump is tested at installation and anytime it is repaired, obviously. Once that initial test or repair test is done, you do the integrity test once every 3 years thereafter. An old containment sump that is choosing to do interstitial monitoring, the owner still wants to do interstitial monitoring, and we do not have anybody like that around here, but I'm sure there are elsewhere in the country. Then you had to have done your integrity test on their old sump by the secondary containment rule implementation date. And then, of course, it's after every repair and every 3 years after that. And so there is another time that we do integrity testing on containment sumps, and whether it's a new or old sump in Mississippi, if we go out, do an inspection, or someone discovers 1/8 of an inch or more of free product in the sump, and that 1/8 of an inch or more just kind of was pulled out of thin air. It came from the groundwater monitoring rule that states 1/8 of an inch or more on top of the groundwater is reportable as a suspected release. Then you must test the integrity of that sump, or you can do a complete site assessment. Either way. So testing the sump, if the sump is tight, next slide, please. If the sump is tight and the free product did not rise above the testing point that you did the test at, then no further action is needed. That suspected release was contained in that sump. There was no release to the environment, therefore there is no release. And so that's the end of story. However, if the sump fails the integrity test, or the level of the free product in the sump was above the normal testing level of that sump, as you can see in that bottom right picture, the free product is above the containment sump itself, is all the way up in the man-waste skirt, so that would trigger an assessment automatically, whether the sump is tight or not. So again, that's just one of the things we've had to try to work out and deal with here in Mississippi. That's become a real question mark when we find free product in a containment sump. What is the appropriate action? Next slide. And then finally, when you talk about containment sump testing, one of the things that bothers me and continues to bother me about the jargon or the language that we use when we describe this is tightness testing versus integrity testing. Everybody calls this, or a lot of people want to call this, a tightness test, when we're doing really what should be just called an integrity test on the containment sump. Because I'm an old guy, I'm an old codger, I'm old school. When you say tightness test to me, that is a quantitative test, and really what you're talking about is a precision test, 0.1 gallons per hour. So that's not what typically happens. We typically talk, when we say tightness test, what we really should be saying is integrity test of the sump. And that really is just the qualitative pass or fail with a hydrostatic test, 1/8 of an inch over 1 hour. There is no leak rate defined. It's just a simple pass or fail. That is more properly called an integrity test. Because again, when you say tightness test, that implies a specific leak rate to me and to most people. And it is possible to do tightness testing on containment sumps. There are a few systems out there that claim to do 0.1 gallon per hour precision testing of containment sumps, and mostly what you'll see that claimed on is the newer dry sump method. That's the fog method. We'll talk a little bit about that here in just a few minutes. And basically what amounts to these little tank gauging probes for the console, they're portable. You'll see these used occasionally. It's really just setting up a magnetic-restrictive probe in the sump and measuring the water level very precisely, just like you do the fluid level in an underground tank. Next slide. So there is this thing again about if the containment sump is double walled and it is monitored, then you do not have to test the integrity of the containment sump. If, this double walled, if you're monitoring. So here, we do specify continuous monitoring is required. This is like doing a hydrostatic test on an underground tank. We consider that to be continuous monitoring of the double walled tank. So similar on a double walled containment sump, we do hydrostatic monitoring. That gets you out of having to do the periodic tightness test or integrity test on the primary sump. And also, of course, these old sumps, if somebody is still trying to do interstitial monitoring on the quote old sump, then they are required to do testing also. But most people don't do that. These old sumps have all been abandoned. No interstitial monitoring goes on. Next slide, please. So let's understand what I mean better about this integrity testing versus tightness testing versus this continuous versus non-continuous. So this little diagram is drawn up to illustrate a hydrostatic monitoring of the double-walled sump. And so this is considered to be a continuous method. You could do this by vacuum or pressure also, although I personally have never seen that done. When we do see this attempted, it's done with hydrostatic, just like an underground tank is. There's a little float switch and a reservoir built into the top of the sump. And so that little float switch is connected to your tank gauge typically, and it monitors the fluid level in that interstitial of that double-walled sump continuously. And so you document this continuous monitoring just like you document the continuous monitoring of a double-walled tank, and that exempts you from having to do the tightness test on the primary tank. Next slide, please. When this initially came out, the rule initially came out, and everybody was excited about not having to test their sumps if they're double-walled. This is the way a lot of the manufacturers responded. What they did is they just built an interstitial port or riser, if you will, into the bottom or the base of their containment sumps. And the idea was you could simply just put a little float switch in this dry interstitial space or atmospheric space of the double-walled sump. And just like we do in a dry interstitial double-walled tank, you could just do monthly monitoring or showing your records are showing that you're doing the monitoring of the interstice of the double-walled sump. And this would exempt you from having to do the tightness test on the containment sump, and that's just not the case. We got this pretty straightened out pretty quickly, that doing this type of atmospheric monitoring does not qualify as continuous monitoring. So even if you have some kind of sensor in a dry interstitial of a double-walled sump, you are still subject to testing the primary sump. Next slide, please. And then finally, this final point of confusion, which I think has really caused a lot of issues and confusion with people, again, about jargon and what we call things. So traditionally, when we said interstitial monitoring, what that meant was and still means is we are looking at the primary containment, and we have some sort of electronic sensor, or we actually could be doing this visually also, where we are just looking at the system to tell if there's a leak or not within the primary containment of the sump. So that is the typical thought of interstitial monitoring. People looked at these double-walled sumps and said, okay, if I do interstitial monitoring of the double-walled sump, then I don't have to do the periodic integrity test of the primary sump. That is confusing to a lot of people, because when you say interstitial monitoring, they have it in their mind already that what you're talking about is monitoring the space of the primary containment sump, not the interstitial. So to me, whenever I have this discussion, I always try to make the distinction that interstitial monitoring is just what you think it is, just what it's always been. But when you talk about monitoring the interstice of a double-walled sump, that is not interstitial monitoring. That is integrity monitoring. So it's hard to get used to saying that. It's hard to get that going in your mind. That no, there's a distinct difference between integrity monitoring and interstitial monitoring. So I have to use different words because words matter, right? So I have tried to get this point across to a lot of people, and everybody still calls it interstitial monitoring no matter what. So I just kind of given up. But think about it in your mind. It's a completely different thing. Next slide, please.
Yeah,
You know,
Kevin, before I move forward, Dylan
yeah,
put another good question in the chat.
okay.
So why are dry tank annulars not required to be functionally tested or continuously monitored, but spill buckets and containment sumps are?
That goes back to the original 40 CFR 280 rule, which I have no answer for. There is no answer to that that is realistic. It's what the cards we were dealt at the time, and it's never been changed. Now, I imagine there were people who wanted to change that rule, but did not get that ever past any of the powers that be for money. It's all about money, right? Testing the interstitial of a double wall tank was never contemplated until the new rules came around. And so no one has ever really pushed that. And I think if they did, they wouldn't get very far with it anyway. That's a great point. It's a great question. Anybody who does double wall tank interstitial monitoring knows that it's fraught with issues also. So hydrostatic monitoring is what most people who are really serious about it are going to do anyway. And hydrostatic monitoring is a really good way to do tank interstitial and sump interstitial monitoring, or integrity monitoring, I should say, right? Okay, so good point, but I don't have a straight answer for you. So then there's this question now about, speaking of money, and how money affects what happens and what doesn't happen. There is this debate, and not really a debate anymore, there used to be, about this what we call high level versus low level testing. So high level testing is required on a new sump. When you first put it in at installation, you have to do this quote high level testing. And what that means is, of course, the sump is filled with water or test fluid to 4 inches above the highest penetration or seam feeding in the sump. So anytime you do a new install, you do this high level test. Anytime a sump is repaired for any reason, the high level test is required. Anytime that you are quote doing interstitial monitoring on that sump and you do not have STP shutdown, then you are required to do high level testing. And anytime a suspected release investigation is going on in Mississippi, they require high level sump testing. Next slide, please. So again, the high level test procedure is pretty straightforward and very simple. All this really is, again, you're filling the sump full of water, you measure it to the nearest 1/16 of an inch, and you monitor this for 1 hour. And so again, the RP 1200 requires that the sump be filled to a level that is 4 inches above the highest penetration fitting or the seam in the sump. So it takes a lot of water to test an STP sump, and measuring that to the nearest 1/16 of an inch again is kind of the trick. And you'll notice that most people who are serious about this will take their ruler or whatever their measuring device is, and they will try to mount it to the sump of the wall so it's not disturbed or bumped during the 1 hour test. Because if you do not have it mounted or fixed, it's very, very easy to come back an hour later, not put the sump, the ruler in exactly the same place, and get a reading that is far different than 1/16 of an inch, even though the sump may have not lost any fluid. So the concept is, again, you have to be able to keep that ruler or your measuring device steady over the course of the 1 hour test. And that's just the only real objective way to do that. Some chat questions about industry practices on disposal of water. Yeah, let's not go there. We don't have the time for that discussion because, and I don't want to talk about it because every state is different. They all have a different viewpoint about that. Some people who do this require it to be characterized for Haswalker or TCLEP analysis on every time you do the test, all the way down to, well, if there's no sheen on the water, you put it back on the truck and you use it as test fluid, and you go to the next station and you use the same fluid again, over and over and over again, until it becomes contaminated. And contaminated is a big question. So there we go. It just goes on and on and on about what to do with the water. Here in Mississippi, it's pretty much you just want to clean the sump out before you do the test so that you don't wind up with a sheen on the water if possible, and you capture that water and take it back on the truck to the next site with you, and it becomes your test fluid over and over and over again. And that's about all I think I need to say about that. It just goes, the argument just goes on and on and on forever. Next slide, please. Just a picture, you know, what the two-piece containment sump. Some sumps actually have three pieces, so that is why RP 1200 requires it to be 4 inches above its highest penetration or sidewall seam, because almost every sump that you put in today, an STP sump, has two parts to it. This is the way a lot of people do this even today and still do it more and more of. The bottom part's put in and the top half is glued in later. So the picture on the bottom right, you look at that and you go, well, that's not a valid test because the test fluid is not 4 inches above that seam that's in the center of that containment sump. And they have not put the top half on yet. So what they're doing is they're testing their penetration fittings before they put the top part of the sump in and glue it in, and they will come back and raise the water level to 4 inches above the seam to test the integrity of the seam. But they want to make sure everything is tight before they put the top half of the sump on. So that's all they're really doing there. Next slide. And so, of course, we get a lot of crazy stuff going on in the South, and you guys have a lot of rainfall, high groundwater issues, and we sometimes have this happen to us. We have to get a vacuum truck out there to try to pump the water out of the sump. And that's not a great picture. I got a little video of this, but it's too much bandwidth, can't show you the video. But the water's coming in through the penetration fitting just as fast as you can pump it out. And so in this case, you know, in this scenario, there's no need to try to do a test again, a hydrostatic test, because when you see water, when you can physically see the water coming in the sump, it's just an automatic fail, right? Okay, next slide. Okay, so this low-level containment sump testing, we'll talk a little bit about that. Low-level containment sump testing was very controversial, and still is in some people's minds, but this thing has gotten kind of crazy, but I'm going to try to put this as diplomatically as I can and still say what I need to say. But if you have a sump that you have electronic monitoring on, and that electronic sensor is configured to shut down any STP that piping in that sump is piped to, then that's one way. So what that means is maybe you've got an electronic sensor out at a dispenser sump that goes into alarm. Let's say it's dispenser 7-8, just as an example. And dispenser 7-8 has both premium and regular grade fuels. And so you get an alarm out there at dispenser 7-8. The low-level testing thing, the shutdown thing, actually allows you to just shut down that dispenser. You do not have to shut down the STP of either product. You just have to shut down that dispenser. So we'll keep that in the back of our minds as we run through this real quick here about how stupid some of this stuff is. But RP 1200, I can tell you the committee fought at length about this. This was a very big issue for the committee at RP 1200 and actually caused, or almost caused, 5 people to walk out of the meeting and resign. I was one of those. So just so you know how these things happen, we got outvoted 6-5. That's why low-level testing is allowed in RP 1200, because the vote was 6-5. But just as we wanted to make, if we're going to allow low-level testing, RP 1200 wanted to make it better than what the federal EPA had written up and required. So that's why example A is specifically spelled out in RP 1200, because if you get an alarm on any electronic sensor anywhere in any sump, The only way to be sure that you're going to stop that leak is to shut down the STP of any product that is associated with the sump that that alarm occurred in. So that still would not fly. It still didn't make everybody happy. So RP 1200 does allow you to have these, quote, standalone sensors that will shut down just a dispenser, for an example. Don't like that. I think that's really stupid, but it is allowed. So we'll talk a little bit more about that coming up. Next slide, please. The low-level hydrostatic test procedure that's described in RP 1200 is very similar to the EPA thing. It's almost exactly like the high-level test, except here, the level of the water, of course, only has to be 4 inches above the sensor activation point. So what that means is if you have a sensor in the bottom of the sump where it's supposed to be, of course, and it's a typical, let's just say it's a typical Veeder-Root 208 sensor, which is nothing more than a little float switch. You've all seen those, they're very common. It takes about 1 inch of fluid on the outside of that sensor to trigger an alarm. So it takes 1 inch of fluid to trigger the alarm on the sensor. So if you go with 4 inches above the sensor activation point, then that obviously means you've got 5 inches of water in the bottom of the sump when you do this low-level test. And that's all you've got. You're just testing the bottom 5 inches of the sump, and you hopefully, or generally, all the penetration fittings are above this 5-inch level. So you're really not testing anything but the bottom of the sump, which is really kind of in itself pretty stupid to think about, because if you think about a typical fiberglass tank, for an example, an STP sump on a fiberglass tank, you know that they have collars built into the top of those tanks from the factory, so that when you install that fiberglass double wall tank, it has that collar built into the STP manhole. And so you glue the quote sump to the collar. Well, the collar itself on the tank is 6 inches deep. So when you do a low-level test on a double-walled fiberglass STP sump, you are not even testing to the top of the collar that came from the factory. So you're not testing anything at all relative to the sump. Not really. You're testing the collar, and that's it. But again, it's just a simple 1/16 of an inch test over 1 hour. Same kind of thing. Measuring 1/16 of an inch at the bottom of a deep dispenser sump is a trick. That's a real trick. Being able to see that and accurately measure 1/16 of an inch at the bottom of a 32-inch deep dispenser sump is just about impossible, which is another reason that I just do not like this low-level testing stuff. Okay, next slide. So in RP 1200, it specifically says, in order for you to pass a low-level hydrostatic test, again, it's 1/16 inch over 1 hour, but the sensor functionality test must also pass. So low-level containment sump testing requires two things. It requires a liquid test at the very bottom of the sump, whatever that is, probably 5 inches, and it requires a functionality test of the sensor. And you say, well, I've already tested the sensors. Well, that may be so, but you have to include the sensor functionality test as part of the low-level test. Okay, next slide. So this is the deal that really was kind of the straw that broke the camel's back, if you will, relative to low-level testing. This allowing these so-called standalone sensors in like dispenser sumps to suffice for monitoring that would allow you to do low-level testing. It's just really bizarre to me, continues to be bizarre to me. And so the question really is no more complicated than if you have a leak in a dispenser containment sump, and you happen to have some standalone device in that containment sump, that is capable of just shutting down the power to that dispenser and that dispenser only? Have you done anything to stop the leak? And so the question is, where is the leak at? Is the leak above or below the solenoid valve of the dispenser? Well, if it is a leak that has anything to do with the underground piping, then that leak is below the solenoid in that dispenser. Meaning that shutting down the power to the dispenser does absolutely nothing to stop the leak from occurring. It has no effect whatsoever. So the leak will continue to happen until presumably someone goes out to the dispenser, and instead of just bagging the nozzle off and saying out of service, which is what's really going to happen, they are supposed to investigate why there's no power to this dispenser right away, immediately. This is going to happen right away. And I'm sorry, but I don't know about you guys, but around here, when you've got a typical gas station and maybe it has 6 or 8 dispensers and one of them stops working, what typically happens is that nozzle gets bagged off on the dispenser that's not working, and they put in a service call, and the service guy will show up maybe in a few hours, maybe in a few days, and depending on where it's at and who it is and what's going on, it may be several days before that service guy ever even shows up to try to figure out why that dispenser has no power. And so the leak is continuing to happen all the time. It just continues on and on and on until somebody figures out, well, it's either running across the parking lot or it's in the ditch or it's in the creek. And this is what is going to happen. We know this is going to happen. It's happened traditionally for years and years and years. It's going to continue to happen. So I just do not agree at all with allowing low-level testing with standalone dispenser sensors. Just very bad idea to me. But we allowed it because quite frankly, there was some lobbying going on within PEI RP 1200. We had to allow it, or I'm not going to say what the alternative was, but we felt like walking out. We should have walked out. I still wish I would have walked out. But anyway, it is what it is. No one does that in Mississippi anyway. In fact, no one does STP shutdown, period. We all do high-level testing here. Next slide, please. Because as we all know, these quote sumps, these double wall systems have been installed since like 1988 or so. People have tried to put in double wall systems all the way back since 1988. And when you're in a wet environment like we are here in Mississippi, or you guys are on the West Coast, water is always an issue. Keeping water out of these sumps is a perennial problem. It always is, always has been. And so many, many people have gone out and just picked up the sensors to get them out of the water, to get them out of alarm. And so this was even without having STP shutdown, right? This was just to get the red light to quit blinking on the Vita root console. When you start talking about having to shut the STP down and shut the whole store down because there's 2 inches of water in a dispenser sump or somewhere, you cannot tell me that people are not just going to pick those sensors up and go about their business, put the service call in, and see what happens. Maybe they show up, maybe they don't. Maybe they make the service call, maybe they don't. And if they do make the service call, guess who is probably going to pick the sensor up to get rid of the alarm? When I was young and naive, I used to think that it was the tank owners that would do these kind of shenanigans. They would go out, open the sumps up, see the water in there, and pick the sensors up. That is not who does this. That is not who does this. Since I retired as a regulator 11 years ago, I've been out in the real world, seeing everything that goes on. I'm a service provider myself. I have come to understand very clearly that it is not the owner-operator doing this typically. It is almost always the service provider, the tech, who comes out and does this. Almost every single time. Next slide, please. Yeah, kind of like the dog ate my homework. Yeah, that's a good example. But yeah, it's almost always the service tech who does this. And so the store owner is back in business. That's all he cares about, typically. That's all, and they think that the service tech has done what he was supposed to do to fix the problem. And that's just the way it is, man. This is what happens. And so I was asked to talk a little bit about dry sump testing. And dry sump testing is kind of weird, right? It is weird. A lot of people look at this and go, "You got to be joking." The guy who invented this process was actually on the RP 1200 committee. Never mentioned a word about this until we got the standard published, but it was just interesting how this all happened. But this dry sump testing method came about because the guy had some experience with a chemical plant. In the chemical plant world, they did this kind of testing under the big concrete paved shops and floors that they had in order to determine if their underground pipes were leaking or not. So this came from the chemical industry. The concept is really pretty simple. You use this quote fog, this heavier than air fog, if you will, and you pull a vacuum through these little, what they call VSTs. You see the guy in the top left-hand picture, he's got a little rubber mallet in his hand. He's drilled a 3/4 inch hole in the concrete near the sump, and he's driving this little VST down into the backfill. And that little red hose you see laying on the manhole cover up there is this vacuum source. When he gets that thing installed, he will hook up that little hose. They will pull a vacuum on that VST, and it will allegedly pull a vacuum through the backfill. And if there is any leak in the sump, it will pull that that magic fog, if you will, through the backfill and into that VST. And next slide, please. So he looks in this little box and he looks for the laser. And if he sees just a dot, that means that there is no vapor being pulled into the chamber. So that's a pass. If he sees what you see in the picture, if he sees the dot and the line, the laser line across the viewing chamber, that's a fail. That means that the fog has been pulled into the vapor chamber. So yes, groundwater was the immediate concern with this system. We all look at this and go, well, how are you going to pull this fog through groundwater? Because we have water all the way to the top of the concrete in a lot of places. So I think that they did not have any good answers for that. And what the usual response was that you would get was, well, if there's groundwater above the bottom of the sump, then if there is any breach in the wall of the sump, the groundwater would come into the sump. So you would see the problem with the sump because you'd be getting groundwater into the sump. And that's all fine and dandy if the water was up to the level where it would test all the penetration fittings or whatever, but you don't always get that. So again, the question became, what about groundwater? So a lot of people said, no, you just can't do this if there's any groundwater up to the bottom of the sump. If there's groundwater up to the bottom of the sump or higher, then you cannot do dry sump testing. And so they came up with some other stuff that made a little bit more sense, like it's been saying, like they have, they're pulling this vacuum, and if you have any kind of groundwater in the backfill down to the depth of these VSTs, you will actually pull water into the viewing chamber. And so I guess there's some logic to that. Now, getting water in the viewing chamber is an automatic fail, obviously. But again, lots of different states have looked at this in different ways, so I'm not going to try to describe what they say or do relative to dry sump testing. It is recognized in almost every state that I know of. There's a couple of states that do not recognize it, some that put a lot of restrictions on it, some that have these trial periods. But the concept is valid, I guess. The question always becomes is, how many VSTs, how far away can they be? So they've done a pretty good job of defining that. You've got to have two on a containment sump, basically. Can't be more than like 8 inches away from the sump wall, that kind of stuff. So I've seen it work. But who knows? Yeah, I guess I'm not convinced entirely yet. Okay, next slide. So the sump fails, and I got to do some repairs. And again, repairs are in accordance with the manufacturer's directions or requirements. So this was brought up earlier. Lots of sumps are getting, quote, repaired, and there is really nothing from the manufacturers relative to what can be done or can't be done to repair a sump. And so you just see a lot of crazy stuff going on. And the pictures you see here are all polyethylene sumps, these plastic sumps, which were very common in the early days of, quote, double-walled systems. Lots of people used plastic. Some still do. And if you know anything about plastics, it's almost impossible to get anything to stick to polyethylene. So if you literally get a crack like the bottom left-hand picture, where the dude cuts the hole in the wrong place, like the top left-hand picture, or the top right-hand picture where the wall of the sump is cracked, it's just almost impossible to fix that crack or sump that way. Polyethylene is a very inert material. There are certain manufacturers who still claim today that they have epoxies and polymers that will stick to polyethylene, but I've yet to see one that I truly believe is effective. And by the way, the bottom right picture is one I had not seen before. This came from North Carolina, and that's 2x4s cut to just the right length to try to keep the top of the sump from collapsing. I've never seen that before. I don't think there's a UL listing on this 2x4s, and I don't think any manufacturer would recognize that. And that definitely is a fire code violation in that. Yeah, that was just kind of funny. I've never seen that before, but you never know what you're going to see. Next slide, please. These are some more, quote, repairs to like penetrations. And again, there are lots of things that are going on these days. The top left is this grape stuff. That's the foam in a can that you get from Home Depot. The bottom left is our old friend Bostic 1100. And they're trying to get these 4-inch chase pipes to seal up. The top right picture is a prominent fiberglass sump manufacturer that we have today. And when they do these kind of molds, you see the cracks in where the octagonal pieces come together, the angles come together, they're all cracked right there. So we actually tried to get a straight answer from the sump manufacturer on what their required repair procedure was for this. And what they basically did is they referred us to their kit that they have for gluing together the top half and the bottom half of the fiberglass. So it's just this fiberglass resin and some mat. That's what they wanted you to use to fix that, which is the cool thing about fiberglass. It's easily fixed. Next slide, please. And so, Christina, how am I doing on time? Where are we at time-wise?
It is 10:07, and we have a break scheduled for 10:20. So you have about 10 to 12 minutes before scheduled 10-minute break.
Sorry, I can't see my clock here.
That's
okay, so interstitial monitoring. I wanted to try to tie this in a little bit with sump testing, because there was this insane argument made, as we all know, that you do not have to test a containment sump in a double-wall piping system if you do not have to monitor. So, okay, the question was, what sumps do not have to be monitored in a double-wall pipe system? And that kind of took me by surprise. I had never anticipated that. I don't think there is any such thing, right? So where this idea came from, I don't know. It's been around a long time, but I think it's finally been put to rest, more or less, but there's still people who don't get this. So I wanted to run through this pretty quickly. If you have a, quote, double wall system and you're required to do interstitial monitoring on the piping system, then if you are required to put a containment sump in, then that sump must be monitored, period. End of story. Next slide, please. So don't have a lot of time, but the thing that really confused me about this, and where this came from, again, I don't really know, but what people were doing, they'd have a typical double wall pipe system, and they would have an STP sump, of course, and a sump under every dispenser. And the double wall pipe would be brought into the STP sump, and typically you would have the interstitial of the pipe open at the STP sump. Okay, that makes perfect sense. But at the dispensers, they did all kinds of crazy things relative to the interstitial. Typically what you would see is these little rubber test boots, like I'm talking about in the early days. The early days when we were building double wall systems, they had these little rubber boots. They were everywhere, everybody had them. And so the little rubber boot was there to test the piping secondary, right? Once you got the secondary of the pipe tested, you were supposed to loosen up the clamp and or back off the rubber boot so that the interstice would be open to the sump. And so that put the idea in everybody's head that if you had a double walled piping system, the interstice had to be open at every sump. I think that's probably where this all started. And what you typically would see, though, would only be two sensors in the pipe system. There'd be an electronic sensor back at the STP sump, and there would be an electronic sensor at the terminal dispenser. So you usually only had two sensors. There were no sensors in most of the dispenser sumps. Again, I never understood that, but this is just the way it was done. Next slide, please. In later days, so we had this thing which came about that people realized that having the interstice closed at the dispenser sumps was not a good idea. Having it wide open was not necessarily a good idea for a number of different reasons, the way we were doing monitoring. So back in 2008, when I had the opportunity to rewrite the Mississippi DEQ rule to meet the secondary containment requirements, I put a very simple phrase in our rule to settle all this. I just simply said that any containment sump in a double-walled piping system must be monitored, period. So that means if you're going to do electronic monitoring, you must have an electronic sensor in every containment sump. Now, whether the interstice was open or closed to the sump really is almost irrelevant, and let me tell you why. So if we looked at a typical piping system, we all know by heart that the interstitial monitoring point has to be the low point of the piping system, right? So we always consider the STP to be the low point of the piping system. So the only point that really was required to be monitored was the STP sump. And so people got that in their heads and didn't put any sensors anywhere else. And they probably had the interstitial open at the dispenser sumps. And so this is how it came about with these so-called crossover tubes and double-walled fittings. People started putting in these crossover tubes, which essentially are just a bridge to get the interstitial part of the double-walled pipe across the single-walled T that was within the dispenser sump. So in this scenario, you have this thing that says, okay, I've got this bridge, my interstitial is continuous across all my dispenser sumps, so it does not have to be open to the sump. Any leak that occurs in the piping system is going to flow back to the submersible STP sump, and that is where my interstitial is open, and that is where I'm going to monitor. Okay, I'm cool with that. I'll agree with that. However, again, this has left things wide open to people interpreting in different ways and lots of different confusion, mostly about how all these different pipe fittings are put together. So if the simple thing is, if you have a double-walled pipe system, you must monitor every sump, period. We all know that. And to me, if you want the interstitial open at every sump, that's okay. If you want to close it at all the dispenser sumps, that's okay, as long as it is open at the lowest point in the system at the STP sump. Okay, so next slide, please.
Yeah, Kevin, Dylan also has a question. He's
Okay.
if there's a standard from PEI or another organization that defines the interstitial monitoring method. They said that he's not found one and that there's some significant inconsistencies in what they're finding.
What PEI standard is it?
No, they're asking if there's a standard.
Oh, is there one? No, there's not one. That has actually been proposed by me as a standard for PEI, and they did not want to do that. They did not want to go there because there's so many different ways these systems are put together and built that they did not want to touch that. But you know, it absolutely should be a standard way to do it, but every manufacturer tells you different things, and because the rule is you follow the manufacturer's requirements. That's what we do. There is no standard that describes how you do this.
Mark agrees with you. He says we definitely need one. And Andrew would like to know, what if the lowest point is not at the STP, but at the UDC?
So again, that obviously can happen in certain scenarios, like in marinas, you see that a lot. And in that scenario, you just reverse it. The interstitial has to be open at the lowest point in the system. And there are some manufacturers who specifically say that is not required. Let me explain that. What their argument is because there's a pressurized system, that it does not matter where the interstitial is open at. If you have a leak in the primary, it will be transmitted by the secondary pipe to wherever the interstitial is open, whether that's the high or the low point, doesn't matter because it has nothing to do with gravity. It's all about pressure. And so they do have a point with that. In the old days, I was old school, and we were all taught that it had to be at the very lowest point in the system because of gravity. And really, that doesn't have anything to do with the way most of the double-walled systems are built today. They do not depend on gravity to transmit the leak to the interstitial monitoring point. It's all done under pressure. So actually, it's not a big deal to me, as long as that interstitial is open at least one place where there is some kind of monitoring going on. So here we are in today's world, new days, finally got this point across that there's not a single double-walled system made where you can say that the sump does not need to be monitored, because it's real simple question you just ask and answer. Is there a double-walled system made today that does not have a single-walled component within one of these sumps? In other words, when you look under a dispenser at the double-walled pipe coming in, they may have all double-walled fittings and all crossover tubes and all of that, but is there some part of that piping system beneath that shear valve that is still single-walled? And there is not a single pipe system built today. That the answer to that is no. There is some single-walled component of every pipe system at every sump. It doesn't matter how you build it, what you do, you are going to have a single-walled component of that pipe system within that sump. So what that means is that sump has to be monitored. And so what that means is that sump has to be tested. So you can't get around this. People still argue about this a lot, but you are going to have to test every sump in a double-walled system. There's just no way around it. And so this monitoring and testing, again, is completely independent of where it's open or closed to a sump. I don't care if they have the interstitial completely closed at the sump, you still got to monitor it. You still got to do testing. So putting crossovers in, and these double-wall fittings and all that doesn't get you anywhere. You still have to test it. Next slide, please.
Kevin, we're almost at 1:20. So maybe if you have another slide or two, and then there's a good stopping point, it'd be a good time to take that break.
Okay, so this was asked me to talk about this, where you're adding old pipe to a new, adding new pipe to an old facility. The old facility has single wall pipe, and they're wanting to add a new dispenser as an example here. That would be, in this example, MPD3 is a new dispenser at an old facility. And so what we would do, what we've always done this, is you put in a containment sump at the old MPD2, and you put in the containment sump obviously at the new MPD3, and you put all double walled pipe, new pipe between 2 and 3. The only place you're required to do interstitial monitoring is at 2 or 3. The interstice has to be open at 2 or 3, and so that's where you have to do the monitoring at. The old single wall pipe remains there. It still looks funny. You got single wall pipe coming in one side of the sump and double walled leaving the other side, where you make that transition. But we have quite a few of these actually done this way. Next slide. And so I'm not going, there's a series of pictures here about the interstice open and closed. This is the old boot thing with the Schrader valve. You see the cap on the Schrader valve is closed. Next slide. Schrader valve still has the guts in it. The cap is off, but the guts, the stem, are still in the Schrader valve. Clamps are in place. That interstitial is closed. Next slide. Here's the old test boot thing again. It's got the Schrader valve with the cap on it. It's closed. Next slide. This is a UPP pipe. This is the newer way they do their pipe system. This is the double wall comes in. The fitting that you see, the big 4-inch fitting there, is the double wall welds to one side and the single wall welds to the other. And it's got a little Schrader valve, and you can't see it in the left-hand picture because they put it directly underneath. So you get your camera on the underside of it. You can see the Schrader valve cap is still in place. It's closed. Next slide. These are the newer, of course, fittings that everybody's using around here these days. It's all fiberglass. Everything's all glassed in. Schrader valve guts, the stem is still in the Schrader valve. It's closed. Next slide. And this is a great question. This is an Environ system. On the left picture, they've got the 4-inch chase pipe open to the sump. You cannot do that with Environ pipe. The 4-inch chase is not secondary containment on an Environ system. It has to have that donut in it. You see the donut's been taken out. There's a double wall fitting that Environ has, and you see where the arrow is pointing to. That's the interstitial right there. There's usually a little orange plug in there, but when you take the plug out, that opens the interstitial. Next slide. This is a great picture. This is a TCI Omniflex pipe. And so that blue that you see, the dark blue, is the coaxial jacket on total containment pipe. It's still in a 4-inch total containment chase pipe, which was also considered to be secondary containment, unless you put Omniflex in. The donut had to be in place on the Omniflex pipe. And you see that the blue secondary, the coaxial jacket, is grown up over the end fitting. And so when we remove this pipe from the ground, and it's laying on top of the ground in the picture on the right, and we cut the pipe up to throw it in the dumpster, there was fuel trapped under pressure in the interstitial of this coaxial pipe. That's just a great video I have. Next picture. Next slide. You tell me what that is. I don't know. That happens around here sometimes. And that actually raises a pretty good point. You could have a sump within a sump. Obviously, doesn't qualify. Next slide. This is the way to go. This is the newer system. This is the loop system by OPW, obviously. Picture on the left, the interstitial port is built into the stainless steel sleeve that you see, and it's wide open. The picture on the right is the same system with the crossover tubes installed. Next picture. APT pipe systems have been done a bunch of different ways. The thing about this one is the picture on the left, the interstice is open on the left, but it's closed on the right. You see the plugs are in the fittings on the right. So this actually would be okay, depending on how they're monitoring. The pipe on the right, where it's closed, better be open at the other sump, right? Some people like to stair step their interstitial this way. I really don't know why, but they do this. The point here again, though, on the right picture is when you've got double-walled system coming in like this, and you've got the interstitial sealed in the MPD sump on both sides of the T, that's a no-no. There's no interstitial communication there. They either have to be open to the sump everywhere, or you've got to have crossovers in. Next slide. More UPP, more fiberglass. Next slide. Double track. That's a fancy pipe with crossovers. Old OPW loops system with crossovers. Next slide. Our old friend UPP, the Schrader valve still has the guts in it. Next slide. This was a really cool picture. This guy had that good idea. Here's the interstitial. He's got a little yellow hose connected to the interstitial on the fitting, brings it up to a ball valve. Is the interstice open or closed here? Because the ball valve is closed, the interstitial is closed. He can open that ball valve and have the interstitial open. And usually you see this done on T's, but the better picture I had was at this terminal dispenser. This is a great idea. I kind of like this. Next picture. Double walled fittings. This is actually Nupi double walled fittings. The way they do their interstitial is weird. You see the top right picture? That funny looking thing, it's not a Schrader valve. If it does not have the crossover tube in it, or it has these little red plugs, that thing is closed. When you're looking at the top right picture and it looks like that, the interstitial is closed. The only way to open it is to have a crossover in it or a red plug. Next picture. Double walled fitting everywhere. Everything is double walled in that picture, including the T. There is no port to get to the interstitial. That's a KPP pipe. You probably never see that. It's Dutch, but that's an interesting picture. Next slide.
That's the last one, actually, Kevin.
That's it. That's it. Okay, cool.
Yeah.
Thought I had one more. All right, we're done.
Okay, well, let's take our 10-minute break. So we'll come back at 10:35 and get right back into it. Remember that at 11, we have Tom Carroll joining us. So be thinking of questions for him. And then the last 30 minutes, we also have set aside as an open for discussion. So the last hour is really your time to ask questions and engage with Kevin and each other. So something fun to look forward to after the next presentation. So we'll see you at 10:35. Thank you. All right, it's about that time. So let's go ahead and jump right back into it. Kevin, I'll hand it over to you.
Okay. And you're going to control the slide presentation.
Yes, I'm sorry, that was misleading. Yes, I will keep controlling it. You go ahead and get started talking.
Okay. Next slide. So this talk was originally given back at the National Conference in Louisville, Kentucky in 2018. It's pretty much the same thing, but I thought it was brings up some good points that the federal EPA had raised in their interpretation of this walkthrough inspection requirement. Next slide. So when we talk about these walkthrough inspections, this is new to a lot of people, and we've had a hard time implementing some of this stuff in Mississippi, actually, because people just aren't used to doing this. But basically, it got watered down to where it's really pretty simple. All it really is once a month, you keep a record showing that you've inspected your spill buckets and looked at the fill cap and the drop tube. It's a really simple thing. And it also required you to be able to look at their leak detection equipment and verify that they had a valid monthly leak detection record, which, I guess you should have been doing that anyway, right? So really all it did was added a spill bucket inspection requirement. The annual inspection does require these sumps to be looked at. And again, this is the federal definition of a sump, which is a little different than what most people think it is. Next slide. So when I got to looking at the federal guidance and the recommendations on this, I remembered that they had this document. It's been around a long time, inspecting and maintaining sumps and spill buckets. Kind of been forgotten about by most people, but it is still around, of course. It does have some good information, and it did provide some guidance on how you do the annual sump inspection that EPA is requiring. RP 900 has been around for several years, of course. It's been modified several times. It required a lot of different things to happen during a walkthrough inspection that the federal rule did not. So the thing about RP 900 is, even though a lot of it was changed to more match better what the EPA required, if you're going to follow RP 900 to meet the federal monthly walkthrough and annual walkthrough requirements, you have to do everything that's required in RP 900, which is more than most people want to do even today. So a lot of states have come up with their own forms for this again, which, you know, everybody loves forms. Next slide. But the monthly thing, what exactly is the monthly walkthrough requirement? So the federal rule did a pretty good job of defining this. It's nothing more than looking at the spill bucket, making sure that it's clean and dry. So around here, and I'm sure it's a common story elsewhere, when we do the monthly walkthrough, we do a lot of water removal from spill buckets. It's always got water in it, or most of them do. Sometimes we have fuel in them. Even today, it's not hard to imagine that a lot of these drivers still will not clean up their mess when they leave after delivery. So at least we get the fuel and the water out of you at least once a month, and we actually look at the bucket to make sure it looks like it's okay. And I guess that looking at the bucket probably is better suited for the once every 3-year testing frequency that the EPA has. In Mississippi, we test spill buckets annually. It's a once every year thing. And kind of, if you look at where the 3-year logic comes from, it's kind of hard to understand because a spill bucket is not designed to last very long to begin with. And if you try to look at the warranty statement on any spill bucket, the best you're going to find is 12 months from installation. So when you buy a spill bucket and you put it in, the manufacturers typically will warrant them for 1 year. So most owner-operators have figured this out, that even though you're only required to do the test at installation and then every 3 years after, they will test their new equipment, their new bucket, within 12 months of putting it in so that they can potentially make a warranty claim. And then all you do really is pop the cap, look at the fill cap, make sure the gasket is on the cap still. And if they have an overfill prevention drop tube, you want to look down the drop tube, and hopefully you do not see the old stick broken off in the drop tube thing. The last part of that monthly inspection is you need to verify that they have a valid leak detection record for that month. So this kind of gets hard to do sometimes because you have these larger marketers who do everything remotely. They have all their leak detection records remotely. They have some third-party guy hired to do their walkthrough inspection. So he comes around, looks over everything at the store. He actually cannot see their monthly records at the store. They're all back at the home office. So it gets kind of a little tricky there, but he can look at the consoles and see there's no alarms, that kind of stuff. And I think that's really the purpose of it. Make sure there's nothing unusual going on at the site. Next slide. So the clean and dry thing, again, is relative. The picture on the left is an unusual spill bucket. Obviously, that one looks kind of weird. That's like a generator tank. That's for humor. Annette knows I have a very weird, dry sense of humor. And we'll come back to that picture later and show you what's so funny about that picture. The picture on the right is how most of them look after a good rain. And you know, we kind of actually like to see a spill bucket full of water when we're going through our walkthrough inspections, because when we get there and open up the lid and we see that it's full of water, that means that that spill bucket is tight. And that's not a bad thing, having a tight spill bucket. And that's really, it's under test almost continually, right? Every time it rains, that spill bucket gets tested. Next slide. And of course, part of the idea behind this spill bucket thing every month is to see that there's something wrong with the spill bucket between those 3-year test intervals, right? So you only test it once every 3 years. So you're looking to see if anything looks amiss or out of place during that 3-year period. Next slide, please. This is the EPA's guidance document. It's got a laundry list of things that they describe that you should be looking for during the annual inspection. So this has shifted gears to the annual containment sump inspection is what this is. And so we'll walk through some of these bullet points real quick. Next slide. Are the sumps tight and sealed correctly? The lid on the containment sump, the STP sump, is by far the biggest issue that we have these days. We've gotten pretty good at making a containment sump tight, but at the STPs, we still cannot seem to keep the water out of the sump because of the stupid lid. So when you're talking about doing an annual containment sump inspection, there's a question that you got to ask yourself. The EPA says you got to do an inspection on all sumps, including old sumps that are not required to be interstitially monitored. So what does that old sump inspection require? Well, obviously, if it's an old sump and the lid is rotted out, I don't think that really matters, does it? It shouldn't matter. Who cares? Next slide. And of course, the next bullet point is, are the sump walls intact? So again, most of the EPA guidance document was geared toward what they call contained sumps, right? This obviously is an uncontained sump in EPA's jargon. There's no double wall requirement here. If the sump wall is not tight, the question becomes, do I have to do anything about this? And common sense finally prevailed. There was a time when people were interpreting the requirement to say you had to fix that. I think common sense has prevailed, and because there is no double wall requirement here at this place where this sump is, there's no need to fix this. Next slide, please. Is the sump free of debris, liquid, or ice? And again, if you're doing interstitial monitoring on a containment sump, that changes the story quite a bit. The bottom right picture is an old sump, does not do interstitial monitoring. Do I have to pump the water out to do the annual inspection? There was a time when the answer to that was yes. And there are certain states that I know of who still say, even though it's a quote old sump, in order for you to meet the annual sump inspection requirement, you have to be able to see all of the components in the sump, meaning that you have to pump all the water out just to do the annual containment sump inspection. Okay, so the top right picture, yes, that's what you think it is. That is Owens Corning fiberglass insulation. And this is from Mississippi, this picture. I'm proud to say. This guy, this is when I was a regulator actually, so I was asking him, man, what are you doing with all of this insulation in this sump? Why is it here? And he was saying, well, I've been having trouble with my leak detectors. So what do you mean? Well, my leak detectors are going into this slow flow mode all the time. And I'll put this insulation in here to help warm things up, to keep it warm. He was trying to use the heat coming off of the submersible pump, use that to heat up the leak detector, thinking that that would stop it from going into slow flow. See, I'd never really thought about that, but nevertheless, he was not required to do interstitial monitoring, so it does not meet the fire code requirements. You can't have anything like that in a sump and meet the fire code requirements, but from a compliance standpoint at the DEQ, it was okay. Next slide, please. This is the picture we looked at earlier where the fiberglass containment sump, and this is a sump that is, quote, old, doesn't have to be interstitially monitored. You see the cracks in the sump where the joints come together, the hexagon joints come together, so does it need to be fixed or not? And again, the answer, at least in Mississippi, is no, you don't have to worry about it. You do not have to do interstitial monitoring. So it's just a structure, if you will, a sump. It's not a containment sump, it's just a sump. Next slide, please.
Kevin, there was a question on the last slide, I apologize,
Okay.
about whether or not the fiberglass was flammable. I know you just said it doesn't meet fire codes, but is it specifically flammable or not?
Yeah. I don't think there's any fire rating on fiberglass bat insulation, even if you take the paper cover off. We really don't know about that.
All right, thank you.
Okay, so here we go. This is an interesting picture. You really can't tell much about it from looking at it. This is obviously a brand new sump. This picture was taken relatively recently, and this picture was taken about 45 days after this brand new store went into operation. So I got a cool little video, and again, we don't do videos because of bandwidth, but there is a union directly under the discharge. This is an FE Petro submersible, so the discharge goes straight down. You see that union right under the discharge. The union was leaking fuel pretty good. It was leaking enough that within about 45 days, about 8 inches of fuel is collected in the very bottom of this sump. You can see it at the very bottom, just above the manhole. And that's just raw gasoline. So again, this is a question. Well, since the leak was below the leak detector, why did it not see the leak? That's a different question. We're not going to go there right now. But they're doing interstitial monitoring here also, right? Yeah, they have to. Why is there no alarm on the system? We're going to come back to that, and I'll answer that question again here in just a few minutes. But the point again is, at least once a year, you would go out and you would see this kind of funny business going on. So that is the primary benefit of the annual sump inspection, if you will, is finding leaks that happen that are otherwise not going to be seen or detected by the mechanical leak detector. And it's just kind of weird that they were doing interstitial monitoring, but they were doing visual interstitial monitoring, which is another thing that the federal EPA rule allows, which was a mistake. It's never been fixed. You really should have never allowed someone to do visual interstitial monitoring, but it's still in the rule. It's still allowed. So theoretically, they would have gone out here once a month, opened the lid, and looked and seen this fuel in the bottom of the sump. But there's another story behind that. We won't go there. Next slide, please. Is it free of staining or new staining? And I didn't understand the point with the EPA between staining and new staining. I don't really know how you distinguish that. But what the idea is here, again, obviously you can see that this containment sump was obviously prepared for the DEQ inspector when he arrived, and they didn't bother to try to wash down. A smart operator would have taken some laundry detergent, thrown it in there, and taken a pressure washer and tried to clean up that ring, that bathtub ring. But this guy wasn't that smart. You can see obviously where the sump is not tight. A lot of cases where the bathtub ring is. Obviously the penetration fitting in this case was not tight. Next slide. So again, well, this is the same picture we showed you earlier. And the thing about the EPA's walkthrough inspection, are the sensors positioned correctly? That's a huge question. If they're doing electronic interstitial monitoring, and they have to do the interstitial monitoring, that is by far the biggest question that there is. And so we're just going to continue to see people pick these sensors up. It's going to continue to be an issue. There is water in the bottom of the sump. That obviously is an issue. And this low-level testing thing, again, all hinges off where is that sensor at, and is the sump tight or not. Next slide. So the penetration questions that the EPA has, they want to know the penetration fittings in good condition. And again, this will be sumps that are required to be interstitially monitored. There's the only place this would really apply. And you see that in this case, the penetration fittings are obviously not tight. But there's no water in the sump and there's no leak because it's a dispenser sump. But if I'm doing low-level testing and that penetration fitting happened to be more than 5 inches off the floor of that sump, I can follow RP 1200 low-level testing requirements and only test the bottom 5 inches of the sump essentially. So if I do that, does it really matter if the penetrations are torn like this or not? And so this is a point that I wanted to make here that got raised quite a few hackles, if you will, because if they are required to do interstitial monitoring, the sump has to be there. In other words, it has to be tight. Even though if you do low-level testing, you can call it tight, you still have to pass the visual examination. So if you were doing low-level sump testing on this bottom top right picture, and you got the bottom 5 inches to pass, you would still have to fix the penetration fittings. So I finally got that clarified and made perfectly crystal clear that that is a requirement. So you would repair the penetration fittings, and then you would have to do a high-level test to verify that the repairs were good. So that's one of the better things we came out of this. The picture on the bottom right, again, the penetration fittings themselves actually look pretty good, but you notice that the donut on the right side is popped out. And again, this is Environ pipe. You see this all the time, all over the country. Environ pipe never had the 4-inch chase listed as secondary containment. It was a patent issue. They could not list it as secondary containment because of a patent fight between Environ and Total Containment. So anytime you see an Environ 4-inch chase pipe open to a sump, that does not meet the requirement if they're required to have secondary containment. All right. Next slide. So again, my question has been and continues to be, when I do this annual containment sump inspection, I get that I can see a leak happening or not. I get that I can see a bad penetration fitting or something if I'm required to have interstitial monitoring. But what else am I looking for? What can I do about it? So this little rating system, Aswamo came up with a little 5-point rating system of their own. This is an attempt to define what's okay and what's not okay. Next slide. That's obviously a brand new system. That's actually a trade show picture, right? Everything's perfect. That's excellent. Next picture. This is a brand new system. It has not even started operating yet. Everything looks perfect and pristine. This is the way they all should look, right? And this is the way I'm sure they all do in Washington State. Next slide, please. So here, this is a plastic sump. It actually does appear to be liquid tight. There's no staining in it. There's no obvious case where you can see that the sump is not tight. So they could be doing low-level testing here. And the equipment looks good. I think really the EPA's idea behind this annual sump inspection was because, if you remember, it all started back in the day when we had thermoplastic pipe. And the question was, if I go out and I open the sump and I look and I see some total containment pipe that's about to fall completely apart, but it's not actually leaking yet, what can I do about that? And surprisingly enough, the answer was not too much. And so now, here in later years, we've got all this stuff going on with ethanol and all this corrosion occurring on all our steel components within our sumps. And so now we go out and we open these sumps and we look at all this ethanol corrosion and we go, what can I do about this? And the answer again is not too much. But this one actually is a diesel system. Diesel doesn't really have much of a problem still. Sometimes they do, sometimes they don't. It just depends. But this is a diesel system that looks okay. Next slide. So this is obviously an E10 system, and you can see it's fairly new. You can tell that by the condition of the submersible pumps. Those are FE Petro twin or tandem STPs, but you can see they use carbon steel pipe fittings, nipples, T's, L's, and you can see they've all got a pretty good film of rust on them already, starting to start corroding up. And so I don't really have any issues with this, I don't think. Everything looks okay to me. Sensors in position, everything's okay. So Next slide. We start getting into questions now about, all right, so this thing looks really bad, looks ugly, but there's no leak. This is what you see in a lot of places these days, right? You see this kind of corrosion going on in these containment sumps. And everybody knows that this is caused by vapor leaks now, right? Everybody understands how this happens now. And it's vapor leaks, but it's not a liquid leak. You cannot see a liquid leak. So what am I supposed to do about this? Is this okay? Is there anything else I can do about it? I can tell the owner operator, man, you're about to lose your system, but what else can I do? Don't know. Next slide, please. And this obviously, you get these degrees of corrosion, I guess. And corrosion is my thing. I'm a CP guy. This has nothing to do with cathodic protection, but entirely different process. But when you see this, you got to think, man, this system is going to start leaking here one of these days. It's not long for this world. But is there anything I can really do about that as a regulator during an inspection? Well, the old question is the system operating as intended? Well, if there's no leak, isn't that the intent? Lots of questions here. Next slide. And yes, you really, what else can you say about this? This one actually is kind of unique because they have the vent tube is a piece of copper, and you see that the little vent tube on the leak detector is actually corroded in half. It's corroded away partially. So this one, you actually could say you have the potential for a leak to happen here. And I suppose that they could be smart asses and just replace the little copper vent tube and say, there you go. But, other than that, it's, again, kind of like the old Environ and total containment pipe issue. The EPA says, well, I don't know what you're going to do about that. It's not leaking. Next slide, please. And so during the national conference, I actually already had pushed it pretty far by doing that WTF, right? I had another acronym I wanted to use for this picture. I decided against it. I thought maybe I was going to push it too far. But you guys all have watched Saving Private Ryan. You know what acronym would I use here? FUBAR, F-U-B-A-R. That's the only way to describe this kind of stuff here. But this actually is in Mississippi. This is a place that I actually do cathodic protection testing at, and the guy was blaming me because my CP system obviously was not working, and I was allowing this to happen. He tried to put the blame back on me. And I said, dude, this doesn't have anything to do with cathodic protection. Okay, next slide. So copper has some issues, obviously. With copper, the picture on the left that's actually a mineral that's called copper acetate, and it comes from the acetic acid from the vapor leaks. We all know how that happens now. The picture on the right is actually a fungus, and we see this where a lot of times where we have water in the sumps also with these vapor leaks, and for some reason there's some kind of fungus, and I don't know what it is, but this black fungus likes to eat copper, and it does so in the presence of these ethanol vapors. I have no idea what that thing is, but if you touched that copper tube right there, if you really literally just went over and touched it, it would just crumble apart in your hand. The copper is completely gone. The only thing that looks intact is really just a fungus. That's a crust. Next picture. And again, originally they wanted you to remove the water, even though the sump on the left is old, doesn't have to do interstitial monitoring. If you ever get in the service business, or if you ever have to fool with these stupid things, one of the most hated things a service guy has to do is fool with the water in these STP sumps, because they are just about as funky and as nasty as you can possibly imagine. So finally got that clarified. in Mississippi anyway, you do not have to remove the water in these old sumps. Next slide. And the mold, the mildew, the bacteria on the left is some cyanobacteria, that red color. It's eating iron. I have no idea how to identify that, but that is a terrible bacterial mess. The one on the right is this really stringy, weird stringy thing that grows around here. I have no idea what actually that is, but that is some kind of living organism there. Maybe it's a slime mold. I don't know what it is, but you can see it plastered up on that white thing right there. So maybe somebody will figure that out for me one day. Next slide. And of course, we should continue to find these sumps completely full of product occasionally. These both actually are old sumps. They don't have to do interstitial monitoring. So this is, again, one of the real benefits of opening all these sumps up is being able to see crazy stuff like this that's been going on with no one having a clue that it's there. Next slide. And yes, our old friend, still find this occasionally. You know, this is how, again, how all this started was, well, if I see a pipe like this, what am I supposed to do about it? What can I do about it? Can I make them replace it? It's not leaking. And I still don't, I've never had a clear answer on that. Next slide. And so, yes, Cheryl, you were correct. Those are spider webs. I guess one particular spider that we deal with a lot around here in the Deep South. And if you look at the top left corner of that picture right there, no, it's not an orb weaver. Anybody else want to guess? You can see it right there, right on the right picture. Who knows what that is? Yes, Eric. Black widows are everywhere in the South. Just about every containment sump you look in, particularly in the dispenser sumps, going to have a black widow in it, more than likely. But this is the first one I've ever seen in a spill bucket. So we always tread real carefully around here. And I think that's it. I'm right on time, am I not, Christina? Yeah, so that last slide. Right. Yeah, that last picture on the right. That's kind of a weird thing. Anybody know how that happened? Do you think they put the pipe in like that? No, he did not put the pipe in like that. That is a plastic sump, and it was a flange mount sump, so that it actually mounts on a little 12-inch flange. It comes out of the bung fitting on the tank, and that's the wall of that plastic sump has completely collapsed. The floor of it has completely collapsed because they did not properly get the backfill up under the sump when they put it in. And so when the floor of that collapsed, it took the pipe with it. And the pipe is not leaking. Can I make them fix that? Can I make them replace that? Same old question. All right, that's enough.
All right. And I believe, Tom, you're here with us, right?
Yes, I am.
Awesome. Okay. So the rest of the hour that we're together is time for discussion. What I've decided to do actually is I'm going to stop the recording for the discussion portions.